There are some classic probability questions that always rear their head when we're getting this introduction to probability like we are now. And those are problems with coins, dice, and decks. Some of these first few pieces of information may seem very obvious, but we just want to establish them in case they're not. Whenever we talk about a fair coin, it's implied that we're talking about an object that has two sides, each of which is equally likely to occur. A fair die, if we had two of them, they would be dice, but the singular version is die. A fair die has six sides, each of which is equally likely to occur. And a fair deck consists of 52 cards, each of which is, again, equally likely to occur. But we have more information that goes along with building what we would consider a standard deck or a fair deck. So a deck also consists of 4 suits, 2 of which are red, hearts and diamonds, and 2 of which are black suits, clubs and spades. And then each suit has 3 face cards, which are the Jack, Queen, and King. Each suit has 1 ace, which it depends on the game you're playing, whether it's counted as a number card, face card, or its own value. But in terms of probability questions, we just treat aces separately. And then there are the number cards, which are 2 through 10. Altogether, that makes 13 cards per suit, which again brings us to that 52 cards total. In example 3, we're told that a fair 6-sided die is rolled. The outcome is the number of dots that show face up, and we want to answer the following questions. Find the probability that the outcome is 5. What we can do to get started is construct the sample space, which would be all of the whole numbers from 1 to 6, since we have 6 sides to our die. And that can help with identifying how many outcomes total we have and how many meet this condition for success. So what we're looking to calculate is P of 5, or the probability that a 5 occurs. There's only one way for a 5 to occur out of our 6 total possible outcomes, which is approximately 0.1667. In part B, we're asked to find the probability that our roll is an even number. We have 3 even numbers, 2, 4, and 6. So there are 3 ways to get that success out of 6 possibilities. So our probability is 0.5. In part C, we want to find the probability that the outcome is less than or equal to 3. So less than or equal to 3 would be the values 1, 2, and 3. So we again have 3 possibilities, or 3 ways to get a success out of 6 total possibilities. So our probability is 0.5 again. Then in part D, we want to find the probability that the outcome is odd and greater than or equal to 2. Looking back at our sample space, 3 is an odd number that's greater than or equal to 2. So is 5, meaning we have 2 ways to get a success from this condition out of 6 total possibilities for a probability of approximately 0.3333. In example 4, now we're dealing with cards being chosen from a deck. In part A, we want to find the probability that a card is a spade. We can reference back up to what we established above, but there are 13 cards in each suit out of 52 total cards in the deck, meaning we have a 0.25 or 25% chance of drawing a spade. In part B, we want to find the probability that the card is a number card. If we were to look back above, we would see the number cards are the numbers 2 through 10. So in a single suit, there are 9 number cards, but then all 4 suits have number cards. So we'd have 9 times 4 possibilities, or 36. That should be over 52, or 36 out of 52 ways that we can get a success for a probability of 0.6923. We can find the probability that the card is odd numbered. Since we only have the cards 2 through 10, our sample space here would be 3, 5, 7, and 9. So there are only 4 cards that are odd, but we have them across all 4 suits. So we get 16 out of 52, or approximately 0.3077. Then we're asked in part D to find the probability that the card is, that should probably say spade. And a face card. There are 3 face cards in each suit, and we're only interested in it being from a single suit, so we'd have a 3 out of 52 chance for a probability of 0.0577.